Okay, so we need to write the rate expression for this reaction. Now before we get into what the rate expression is, we need to balance this reaction. So what I like to do is to put all of the elements in the middle. So we have a C, we have an H, and we have an O on both sides. And then do little lines out to the side. And as we're balancing, we can put the numbers and adjust them as we go until we have the same number of like carbon atoms on each side, hydrogen atoms on each side, and so forth. So the first thing that we're going to do is we're going to write all the numbers down. So there are 7 carbons, and over here there's just 1. There are 14 hydrogens on this side, and over here there's just 2. There are 2 oxygens on this side, and over here there are also 2. So first we should balance the carbons maybe. So we can add a 7 here. This changes to 7. The O changes to 7 times 2, which is 14. So, 15, because we have another one over here. So then on this side, we can do, let's just do 7 for now, because that will get us 7, 14. That's at least closer. So now the hydrogens, we can add a 7 on this side because 7 times 2 is 14, so that makes this balance, but then there's the oxygen that we have to worry about. So 7 plus 14, which is 21. So on this side there's going to be 21. So now on this side, what we can do is, since we have everything else balanced at this point except this one oxygen molecule, we can do a fraction and then multiply the entire reaction by the denominator of the fraction that we make. So the fraction we make over here is going to be 21 over 2, because over 2, that gives you the perfect amount of oxygen so that when you multiply it by 2, it will be exactly 21. See how this little thing works out? These cancel and you just get 21. It would be much harder to balance this and just keep adding and adding and adding numbers. So now we're just going to multiply the entire reaction by the denominator of this fraction right here so that everything is whole number. So it's going to be 2 C7H14 gas plus the 2 cancels out on the bottom of the 21. So it's just going to be 21 O2 gas, which goes to 7 times 2 is 14 gas plus 7 times 2 is again 14 of the water. So this is our balanced equation. So now the rate expression just states that the change in whatever molecule over the change in time is equal to the rate. But the only thing is that we have to add coefficients to this. So your rate is going to be equal to the negative, or the inverse of the coefficient times the change in this molecule over the change in time. So let me show you what I mean. So for reactants, the coefficient in front of the rate expression is always going to be negative because you're losing reactants as you're gaining products. Reactants are forming together to form these products, so you're having fewer of these and more of these as the reaction goes on. So the rate for like this, for example, is going to be negative 1/2 change in C7H14 over change in time. It's also going to be equal to negative 1 over 21 change in oxygen over change in time. So then it's also going to be equal to the positive 1/14th change in CO2 over change in time, and the positive 1 over 14 times the change in H2O over the change in time. So this is our rate expression. And the only thing we need to know about this is that these things are constants, so it's not like you have to plug anything in for these individual like things. Like you would never have to plug in like time or like the change in CO2. It's just if you have a rate that's equal to, let's say, 3.7 times 10 to the negative fourth. Let's say the change in C7H14 is equal to this. You would do negative 1/2 times 3.7 times 10 to the negative fourth, and that would give you the change 14 over the change in time, because this entire thing is 1 unit. So that is how you write the rate expression.